Hi students, in this video lecture I am going to cover the last unit because I hope that I covered all the units except one unit, that is window and viewport. It's the last unit. Window and viewport and the transmissions, some of the algorithms that I have to cover in this last unit, and we will discuss regarding of all topics that are given in this window viewport chapter in detailed manner in coming lectures. I hope that you are preparing well for forthcoming examinations, and I already suggesting you, if anyone not clear regarding of this concept, you can call me directly, you can ask any doubt if you have related to the topics that I discussed in the class or that I discussed in these video lectures. And one more thing, I suggesting you, if you have more comfort with your mother tongue, so I already posted many videos in my channel and other channels also. They are also explained beautifully in your mother tongue with the animations, with the beautiful examples. You can go through those channels also, and websites also. Some tutorial points are there, Java point, tutorial point, and some other websites are providing the Vidyagate. They are providing very good information that is related to computer science and engineering. If you have any doubt, you can go through those subjects or other YouTube channels, and you can take the my support understanding of the concept. Anyway, be serious in your studies and don't waste your time, and utilize this opportunity. Learn from your home, work from your home. This is opportunity that is given to you. Do whatever you want to do, but don't waste the time. Now I am going to discuss viewport and window port. What is the viewport and what is the window port? We will see with the example. As for the syllabus, so we have to cover so this is our syllabus. This is a 50 unit that we have to cover as per SBT for our forthcoming examinations. So window port and viewport, and elimination of total visible and totally invisible lines with respect to a rectangular window using line end point codes. Line end point codes. Rectangular window, I will tell you it is a rectangular window. I will tell you what is the window port, what is the viewport, and how eliminating the visible and invisible lines with respect to a rectangular window. And then the next topic is explicit line clipping algorithm. Explicit line clipping algorithm. Then Sutherland coherent algorithm, midpoint subdivision algorithm, polygon clipping algorithm, polygon representation, inside outside test polygon. So the filling algorithms, stock based, queue based, seed filling algorithm, and scan line fill algorithm. These are the algorithms, concepts, topics that we have to discuss in this unit. So we will explain, or we will see each and every topic in detailed manner in forthcoming video lectures. For time being, I want to give the introduction regarding of what is the window port and what is the viewport and window viewport transmissions. Up to that, I want to cover in this video lecture. Look at here. Window port. What is the window port? What is the window port? The world coordinates are selected for display inside a window. World coordinate area selected for display is called a window. So I will show you what is the window. What does it mean? For example, here, look at this is my camera. I am moving this camera here and there. This is the camera here and there. But I can enlarge this one. I can enlarge this camera, and I can enlarge this one camera again, and I can enlarge it. So I am enlarging this camera. Now, displaying fully in entire screen. In this entire screen, I have selected minimum, max, min and max area. Okay, I'm selected. This is the maximum area that I can cover. This is the maximum area that I can cover. This is the maximum area that I can cover. So now you are able to see my video lecture in this window. This area selection, I selected this much area for showing something, display something on a monitor. This much area I selected to display something on the monitor. This is called a window. This is called a window. So the window is nothing but the selected area for display something on monitor or screen. The selected area. So this is the entire screen. This is the, I think this my screen size is nearly 10 inches in screen is there. Just imagine 10 inches. Just example I am telling. I don't know exactly what is the size of the screen, but I am telling. Just imagine this is a 10 inches. So out of 10 inches, now I am selecting the 8 inches. This is the max area that I can cover. And the area selection for displaying, this is called a window port. Now look at here. Now in entire area again, this much area I cover. Now this is become as a window port. Now in entire area I covered this much. Then now it become a window port. Now this much I selected. This much I selected. This is a window port. Now this much I selected. This is a window port. So this is called a window port. World coordinates area selected for display is called selected for display. So that is called a window port. In computer graphics, window is a graphical control element. It consists of a visual area containing some of the graphical user interface of the program. It belongs to and it's framed by window decoration. A window defines a rectangle area in the world coordinates. You defined a window with window statement. You can define the window to be larger than the same size as or smaller than actual range of data values, depending on whether you want to show all of the data or only part of the data. So what it tells about a window size, we can enlarge it, we can enlarge the size more than actual data, more than, or you can make the image smaller than the actual image. Anything you can do it. So both we can do it. do it. First thing is you can enlarge the data. The second thing is you can minimize the data. So I will tell you, I will give the one more example for this. Look at here. I want to show this picture. I want to show this picture, and what you are able to see on this monitor, this entire part called what I am trying to show. Okay, that area, for example, so entire part I covered this much area. Okay, I'm talking about only screen, my mobile screen. I'm talking about only my screen, what I am presenting. I'm not talking about the picture what I am showing on your monitor. I'm talking about regarding to my mobile. So lot of area is given, but I don't want to show this side and this side and upside and downside, but I'm focusing on, I selected this area. I selected this area for what? The presentation, to show something. And this area, this is what? This is a window. What this one? This is a window. Okay, what is that? That is a window. Simple. The area that selected for display is called window port. Now what is telling, what is the actual size of that object? Using of the window, you can enlarge the size of the object. At the same time, you can minimize the size of the object. You can reduce the size of the object. Look at here, I will do that. How can I do that? Imagine this is the actual size of this one, this area. Which area? So this area I selected for showing something. Okay, that one you are able to see here. So what area selected? I mean, large area is there, but some area I selected, and that area you are able to see here. And this is called a window port, this is called a viewport. We will see what is the viewport also. Now listen. So what I am trying to say, this is the actual size. Just imagine this is the actual size. This size I can enlarge it, or I can reduce it. How can I do that? Look at here. Okay, this is the, now listen. What? How can I do it? Now listen. Enlarge the area, but this is not the actual size of the area, but I enlarged it. At the same time, I can minimize it, reduce it. Look at here. Am I doing? Minimizing it. So using of the window port, the selected area, you can display the size of the actual object or thing or anything or any picture or any image, any scenery. You can enlarge it or you can reduce it. This is the actual window. This is the window. Look at here, it's already mentioned clearly. This is the window port, the area selected. So here y max and y minimum value, and x max and x minimum value. So the area selected, the coordinates x max, x minimum, y max and y minimum. These coordinates, where the coordinates are fixed, that area will be selected. That area, which area we selected, that area called window. That area called the window. Window port or window port. Next we will see the viewport. What is the viewport? Look at the definition for the viewport. An area on display device to which a window is mapped is called a viewport. an area on display device, an area on display device to watch a window is mapped is called a viewport. A viewport is a polygon viewing region in computer graphics. The viewport is an area expressed in rendering device specific coordinates, example pixel per screen coordinates, in which the object of interest area going to be rendered. A viewport defines a normalized coordinates as a rectangular area on the display device where the image of the data appears. You define a viewport with the gport command. You can have your graph take up the entire display device or show it in only a portion, says that upper right part. So what is the viewport? So viewport is nothing but a device that shows the window. In a device, it shows the window port, that area, that one called as a viewport. That one called as a viewport. For example, I will tell you. What is a viewport? Camera. Okay, camera, while when you are seeing something, when you are take the picture, okay, when you want to take the snap and you want to zoom it and zoom out, zoom in and zoom out, and you are selecting the area, how much size you want to take the picture, full picture image or passport size image or off image. You will select the area. That selected area is called window port. Okay, so how much area are you selecting for capturing? Lot of area is there in real world. Lot of area is there. For example, mountains are there. Many mountains are there. Many in a mountain range, many mountains are there, and that many mountains may not covered. It is impossible to cover all the mountains at the same time. So you can cover the capability of the camera capturing capacity. It depends on the capturing capacity of the camera, the pixels, that much only we can cover. So here the area that we can cover, or that area that you are selecting, the selecting area displaying on the camera, the displayed area on the camera, okay, a camera view, a showing of on your device, that is called viewport. That is called a viewport. That is called a viewport. How much area you selected, that is called window port. The selected area display on the monitor, are able to see on the monitor, are able to see on the camera, are able to see on the device, that is view that you are able to see, the range of view that you are able to see is called a viewport. It is called a viewport. Here two things are there. A window is nothing but in mountain range, many mountains are there, but we want to take the picture of the Everest. In Himalayas mountain range, many mountains are there. K2 is there, Everest is there, okay, K3 is there, okay, like that many mountains are there near Everest. But now we want to focusing on the only Everest mountain. We want to take that picture. Now Everest become a window port for you because this area selected. Many mountain range you want to take the only picture of the Everest. Now it is selected the max and minimum size of the window. Okay, now that become a window view. a window port. Now how much area you selected, that much area displayed on your camera or device. Okay, that is called a viewport. It's called viewport. We will see understanding of this concept with the example. You see the mini example to understand this concept. I want to give the mini example. Look at here. Just imagine this is Everest mountain. Just imagine this is the Everest mountain. Okay, this is the Everest mountain. Okay, imagine. So many mountains are here and there, but you are selecting only this part. You are selecting only this part. Now this area become a window port. Now which area you selected, that one only you are able to see on your camera. Okay, this one is a camera device. This is a device port. Okay, now listen. In your device, camera capabilities, it can capture the lot of area. It can capture all this area, but you are fixing the coordinates up to here only. What the area fixing, that much only showing on your camera. Your camera. So for example, in my camera, while I am teaching this lecture, this camera can cover all my room, everything it can cover. Thing means it can cover, but I am focusing on only to showing of myself while I am teaching to you. So now the capacity of the camera, it can cover a lot of space behind of me, but I am selecting only particular area, that is for example me. Now it become a spot become a window part. What the camera is selecting, so what I am fixing, this fixing points become a window port, and this one able to see on my screen. Okay, now areas are selected become window port. Now in this big screen, lot of big screen is there, but in this big screen, so this much, sorry, just look at it. In this big screen, okay, in this big screen, this much only. In this big screen, this much only. This is big screen. This much only showing on one monitor, on my device. This is the camera. Okay, this much only it will show you, and this is called viewport. This side space is there. This side space is there, but this much only showing on camera, and this view called a viewport. This space or this part called a viewport. Okay, so it will selected area called window port, and what the selected that showing on a camera, that part called as a viewport. This is the difference between the viewport and window port. And let me see transmissions, window port and viewport. Just I want to introduce the transmissions, and they will see different algorithms in forthcoming lectures. Look at here. So I want to give one more example to understand this concept clearly. Understand the concept clearly. So what are the example? Window. Look at here. This is the world coordinates. This entire scenery is the beautiful scenery. In this beautiful scenery, so here covering in this beautiful scenery, Okay, this much only covering the black, okay, square part only covering or selecting, that one called a window. And this what the selected point showing here, it's become a viewport. Both are side by side, window port and viewport. Look at here. In a real world, selecting area called window port. What the area we selected are showing on the camera is called a viewport. Okay, let's see. Transformations. Transformations involves developing formulas that starts with the point in the world views, say xw and yw. Okay, x are both are coordinates and w is the window, and y view means y coordinates in a viewport, x view means x coordinate on viewport. So here transformations are there, scaling, translations, scaling factor sx, xy. So how much? For example, sx scaling factor, you will see the only formulas. Sx equal to xv max minus xv minimum. Xv max minus xv minimum means viewport max minus viewport minimum on x-axis. W max minus xw minimum means x-axis or x-coordinate in window max minus x-coordinate window minimum. That is the x-axis scaling factor. And then x-axis over, then now we'll see the y-axis on scaling factor, yv max minus yv minimum. That means viewport y-axis maximum position minus viewport y-axis minimum position divided by window max minus window minimum on y-axis. This is the scaling factors, the formula that we have to follow. And what we will do when you want to change the scale, then we have to substitute the mathematical values here. Then we will get some mathematical expressions. And then next one is the transformation. This one is the translation factor, Tx and Ty. S is the scaling and T is the translation. Scaling for what? Scaling is nothing but increasing of the size, reducing of the size of that viewport, the window port. Now listen here, translation nothing but changing of the position of the window port or viewport. Look at here. So now translation factor Tx equal window max into window minimum minus window minimum into window view max divided by window max minus window minimum, and t axis, and ty y-axis window max into view min minus window min into v max, window port minimum area into viewport maximum area by window max minus window minimum. So these are the positions for changing, that is called translation. Translation nothing changing of the position, scaling nothing but increasing of the size or reducing of the size. So these are the transformations that we are going to follow in view and window port. So look at here, the position of the viewport can be changed allowing the objects to viewed at different positions on the interface window. So what is telling, the positions of the viewport can be changed. Positions of the viewport. So what is the positions of the viewport can be changed. So my camera is the just viewport here. My camera is the viewport here. So what is this point is telling? The positions of the viewport can be changed, allowing the object to be viewed at different positions on the interface window. Look at here, this interface window. Just I am changing the positions of the viewport. So just I am changing here, 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 or here, or here, here, top, corner, middle. So I am changing the positions of the viewport. That is called translation. I am changing the size of the viewport. I am changing sizing. I am changing the size. It's called scaling. I'm changing the size. Okay, this is called scaling, and changing the position is called translation. It's called a translation. So these are the transformations that are in window port and viewport. I hope that this concept is very clear to you. So if you have any doubt, you can call me and you can test in WhatsApp. Thank you so much.